All right. Uh, so why don't I give a quick introduction to me? Hi, everyone. My name is Daniel Steger. I am the Technical Community Manager at the Center for Open Science. I'm joined today by six fantastic presenters. Each of them are going to have 10 minutes to give you a wonderful talk on all sorts of fun things in open science. First one here is going to be Maria Pawlowski. She's going to talk a little bit about open science policy and co-creation in the Nova Scotia, Canada. Maria, if you want to get started, you have 10 minutes.
Thank you so much. So I am I'm so pleased to be here. Can I just start with apologizing for my somewhat nasal voice? It is head cold season here. So, okay. I was told today it's pretty bad. So I just thought I'd mention that up start. I am coming today to you today from Mi'kma'ki, and the part of Mi'kma'ki that I am in, it is the unceded and ancestral land of the Mi'kmaq people, which the part I'm in today hosts the province of Nova Scotia. Now, this is Nova Scotia. For those of you who might not know, there are Canadians who are not exactly sure where Nova Scotia is because it's that small little part in red at the end of the huge bit of North America that is Canada. So this is what I'm going to be talking about, this particular projects we've been developing in this part of the world. Just up front, what our areas of focus are. They are centering the research community's needs. And when I say research community in terms of open science, I mean the very broad research community, the whole ecosystem, really. We're talking community colleges, we're talking teaching universities, and the big research university we have here in Nova Scotia, Dalhousie. And we're talking librarians, grad students, tenured professors, track tenure staff, technicians, administrators. We're talking everyone. I think I've spent years working in science policy and administration, and I think one of the biggest mistakes people make is assuming that tenured professors are the only people one should talk to when designing research policy. So we very much did not do that. We talked to everyone we could and whoever would want to speak to us. Importantly, we also spoke to community members who work with researchers for all sorts of reasons, because this is open science. We talked about challenges as well as opportunities. Every time I met researchers, and I'll give you the numbers of how many people I talked to and people in the research ecosystem, I was always very clear on the fact that if you don't tell me about them, they will still exist. However, if you tell me about them, maybe we can do something about that. And thirdly, we prioritized community input. So it was very much about what it is you want done and how can we help you achieve this. And another part that was very big for us was data sovereignty. So that is particularly in terms of First Nations and Indigenous people and the African Nova Scotian community here in Nova Scotia. It's about establishing an appropriate framework, but also using frameworks that have already been established. So when we speak about data sovereignty, we make sure that data belonging to Indigenous people or African Nova Scotian people actually stays with them, whether this is Indigenous knowledge, Indigenous material culture, whatever it is. We make sure that data sovereignty and their ownership of the data, information, material culture is prioritized. I don't think I need to mention the awful history this continent has had in terms of interactions with the Indigenous people. And we wanted to make sure that we want to be no part of that. And this is the framework with which we want to work. So here, I'm not a quotes person, but I think this is a really good quote for what we've been doing. And I'll just read it to you. A policy-driven co-creation process is a series of complex and often magical moments during which people take the most important resource they have, time, coupled with their visions, desires, and knowledge to address together a compelling issue. This achieves results that cannot be achieved individually. And this is the Co-Creation for Policy Handbook. So this is exactly what we were doing. And what is it then? What are the details? So I was working with Research Nova Scotia on this, which is the provincial funder for our province. I don't work with them, for them. I am just an external expert for this particular project. And we developed a survey in terms of learning what the current practices are. There were workshops, and I didn't call them policy co-creation workshops. I always felt like, an evil bad guy from Bond movie pulling off my mask when I eventually did tell people it was a policy co-creation workshop, because people don't feel qualified to do policy co-creation. They think because they don't necessarily feel they know enough about open science. Whichever the policy we would create, it would affect them, and we wanted to make sure it aligns with their needs and lived experiences. So we called it open science workshops. But they were designed in the policy co-creation framework, and everything we did, the goal was to work together to see what would work best for the province. And because of how diverse the province is, because we have the community college, the teaching universities, and the big Dalhousie, the sort of powerhouse of research, we really believe that the work that's been happening and the results we have are transferable not just to other provinces, but probably other parts of the world as well. I've designed a tailor-made policy for Nova Scotia, and there will be a roadmap to show us to hopefully work out how to get there. And then hopefully one day Research Nova Scotia will launch this policy, but I am contractually obliged to tell you I can't speak for whatever they intend to do with it. And so just to show you some numbers, the project midway, we've spoken, mostly me, to over 250 individual participants. I've personally spoken to over 150 of those people, whether in workshops or individual interviews. The project included 15 Nova Scotian institutions, which is almost all of them. 8 policy co-creation workshops throughout the whole province. We made sure that, literally the whole province. The wonderful thing, there's many wonderful things about Nova Scotia. One of them is that you can drive the whole province in a car. That is not you can drive some Canadian provinces in a car, but I could do this in one day, which again, not all Canadian provinces you can do that in. So we drove back and forth through the province, conducting these policy co-creation workshops, and we did 7 outreach events. And so what is it? What did we get to? I feel like I was really hoping to get through all my information, and I did, and I get to actually tell you where we are at. And all this will be published, hopefully, that the project finishes June of this year. What's going to be published depends on Research Nova Scotia. I hope they publish all of it because it's wonderful information as far as we can tell. And I've been working with experts from all over the world. This is the biggest project of its kind in terms of people involved in policy co-creation in open science. And when we were thinking of open science, when we designed this, we're thinking obviously open access and open data, but also involving other ways of knowing, particularly Indigenous people, and research infrastructure. So we're taking the whole UNESCO definition of what open science is and literally driving through the whole province and talking to researchers, research administrators, again, graduate students, about how best to do this in our province, and hopefully also other places around the world, because of how diverse the ecosystem here is. And I think that the wonderful, inspiring lesson has been of how much is already happening in our province. Nova Scotia, as you could see, is a bit of, we're in a bit of an end of the world kind of situation. And even though here we are, we have been able, as I've been learning, to do things that are absolutely wonderful in terms of open educational resources and working with Indigenous communities and community-led research, as well as, for example, working with patient partners. All of this has been happening in Nova Scotia with very little support. And what comes up all the time, and is, I don't think, going to be surprising to any of you working in open science, is research assessment reform. And I think that's going to be the next big thing here. And my report is very much about 3 things: lack of resources in terms of time, money, and knowledge, about the prestige problem. And someone was saying the other day that they start to get a skin rash when they hear the word prestige. And I know exactly what they mean, because I do feel at this point like I'm developing an intolerance to the word, because every time people talked in all of these events, they were like, yes, we want to do it, but prestige, but tenure. So then it comes down to research assessment reform. And that is why I'm thrilled, but also just a teeny bit horrified about all these reports and policies we're putting in place because they require so much more than just researchers wanting to do things differently. We really need institutional change, both from the funders, and it's exciting to be working with a funder because they literally pay your bills. And you don't have to like them, and you'll still probably do what they ask you to do because, again, they pay your bills. Yes, I have 1 minute left. So that's why it's wonderful. And I really hope we can enact some change because, just south of the border of Canada, we've got the federal government in the US doing some exciting things with open science. And we think we might be the first province doing exciting things with open science and going beyond open access and open data into, for example, putting into the policy respecting data sovereignty and practical tools to do that. And here I'd just like to give a shout out to Local Context, who have been wonderful supporting me in this, in terms of using or helping with their framework that they've developed for Indigenous labels for preserving data sovereignty. So I'll just leave it at that. Thank you very much. And again, excited to be here, excited to hear the rest of the presentations.
That was fantastic. Thank you, Dr. Prawalski. Next, we're going to pass to Elizabeth Drellick, who is building open science skills through open source education and initiative. I'll let them start to share their presentation, but I'm excited to hear what you guys are going to talk about.
Hello, I am trying to share. I'm not sure that it's actually letting me.
Let's see what we got.
Sorry, I had to re-download Zoom, so it's checking my system preferences. I'll be right back.
No worries. If that's the case, we can just skip quickly. We will go to our third presenter, Rose Hartman, with Open Education, Open Science, a training program for biomedical research, reproducibility, data science skills. So we will skip and then come right back.
Hello, I'm back.
Oh,
Sorry for that delay. I should be able to share now. I know everyone was practicing before and I was like, I can totally do it, but I was wrong. So you should be able to see my screen, and I'm gonna turn this into presenter view. Can you see my slides?
You are all set.
Excellent. So hello, my name is Elizabeth Drellick. I use she, her pronouns, and I'm a data science educator at the Children's Hospital of Philadelphia, which is also known colloquially as CHOP. And I'm very excited to tell you about some of the educational work we've been doing over the past few years. I'm going to tell you about what's happening next and invite you to use or even participate in some of our work. So here at CHOP, we work with a lot of biomedical researchers who are studying clinical data, but they don't have formal training as data scientists. They want to make their research as open as possible. They want to comply with NIH guidelines for data sharing, but they don't really have a lot of time to learn how to do that. They don't even know how to figure out what they need to learn. I'm going to tell you today about the data skills we have found biomedical researchers need to do the work of making their research open, as well as introduce the Data and Analytics for Research Training Program, or DART, that we built here at CHOP to help with that training. My colleague Rose Hartman will be talking about the program's effectiveness in the next lightning talk, so stay tuned for that. And at the end of my talk, I'm going to share some of our plans to turn this into a permanent, sustainable resource available both for our researchers here at CHOP and worldwide, and also share our materials, which are licensed under Creative Commons share and share alike. Also ask for your help. So when working with biomedical research, our focus is to make sure that the methods used to process and analyze the data are as open and reproducible as possible. And what that means for us, because our data obviously needs to be quite secure, it's governed by both HIPAA and IRB, is that we need to be using open source software to ensure that if someone wants to reproduce your study, they do not need to invest in potentially thousands of dollars of software license or backups. We also mean that you should be using scripted analyses instead of point and click statistical tools, so that when data analyses need to be reproduced, either for new data coming in or to replicate and verify the work, there's no complicated instructions for what to click in what order, just a script that runs and does exactly the same steps every time. It also means that we're using literate programming tools like RStudio or Jupyter Notebooks that can interweave code blocks with clear descriptions of what each block does, so that the researcher and others can not only run the analysis, they can also understand what each and every step does. In more concrete terms, this means that we are teaching people to do their analyses in R and Python rather than proprietary languages like MATLAB or Mathematica. We are teaching people to use SQL to query databases rather than manipulating CSV files with point and click software. And we encourage all of the work to be done in Jupyter or RStudio labs, where markdown descriptions of what is happening and why it's happening can be easily written right next to the code. So we built the Data and Analytics for Research training program to teach our biomedical researchers why those technical skills are so important, to provide them with the training to use the right tools for their research. And we connected learners to curriculum made of short, focused, asynchronous, modular educational materials. And we connect them based on their answers to a survey about their interests, needs, and expertise. We had over 500 participants go through our initial study in 3 different waves over the course of the last 2 years in 2022 and 2023. And I might have mentioned before that this is funded by the National Institutes of Health, and you'll hear more about that from my colleague next. What I'm going to focus on is how we built the program and where it's going. So when it comes to our educational materials, we wanted to make sure we practice what we preach. All of our educational modules are open source and available on GitHub. And there's a link here for you to see our GitHub repository. You can use them with all of their sleek, shiny, interactive quizzes and coding exercises, but the materials themselves are actually written in Markdown and rendered by LeaScript, which is an open source interpreter for interactive educational content. And our entire repository is licensed under a Creative Commons share and share alike license. So you can use these modular courses exactly as they are, or you could take them and remix or rework them to fit your needs. And you've got links to see them. That first link is a list of them all rendered nicely. And the third link will bring you to their raw form. But having a large number of modules available to teach these skills doesn't solve one of the main problems I mentioned at the beginning. How are you supposed to know what to learn? So for our study participants, we created specific pathways of modules based on their survey responses. And this was a pretty labor-intensive process that we'd really prefer to automate. So we've published 5 of our most popular pathways so far, and we're building a tool right now to help people build their own learning pathways. If you happen to have a minute, we'd love for you to check out our prototype of this tool and give us feedback on whether you found it useful. And of course, this is also open source. The code for it is publicly available on GitHub. So the NIH funded research portion of this study is wrapping up, and we're hoping to publish soon. But the program continues to grow and evolve as we make it into a permanent educational resource. And we're always looking to improve our offerings, both by improving the modules we already have and by expanding with new modules. And a knowledge graph of the modules is helping us connect them into pathways to see where more courses are needed, where someone should take a course that they might have missing information on. We're also working on building a recommender engine to suggest pathways to learners automatically, and we're currently in the process of applying for funding to build that engine. So I phrased this in the title of the talk as an invitation because that seemed a little more warm and fuzzy than just asking for your help. So I actually have several invitations of ways you can get involved. So if you are even vaguely interested in hearing more about this project, You can take 20 seconds to sign up for our mailing list, which will send you a newsletter approximately 3 times a year. If you have a few minutes to explore our prototype, we'd love to hear what you think about it. This is our prototype for how to build your own pathway of learning modules. There's a survey you can fill out to let us know what you think, and your comments will have a big impact on how this tool develops. If you have between 15 minutes and an hour, you could try out a module. And there's over 60 of them on everything from Dockerizing your code to how to start getting involved in omics or genomics research, things about how to code in R, and things about how to use geospatial data in your research. And none of them are longer than an hour. You can also share these invitations with anyone, colleagues, friends, students, mentors, anyone who you think might be interested. And lastly, if you have the interest and rather a bit more time, there are lots of ways that you can contribute directly to this open source project, all of which you can find described on the GitHub page. So I just want to thank you so much for your time in attending this lightning talk. And I hope you accept my humble invitations to contribute a few minutes of your time. I also want to give a thank you to all of our contributors and the National Institutes of Health. So thank you so much.
Wonderful. Thank you, Elizabeth. And I believe Rose was putting all of these links in the chat, so please take the time to look at those. Now, I will actually pass to the aforementioned colleague, Rose Hartman, so she can continue talking on this topic from the Children's Hospital of Philadelphia. Go ahead.
All right, is that showing up okay?
Yep.
All right, thank you. So hello, my name is Rose Hartman. I use she, her pronouns, and I am also a data science educator at the Children's Hospital of Philadelphia, along with Elizabeth. And I'm going to be continuing the theme from her talk, talking about our approach to teaching open, reproducible data science skills to biomedical researchers. As efforts like the Year of Open Science bear fruit, more and more researchers recognize the value of transparent science. And yet many find themselves without the skills necessary to translate those values into behavior. Some open science behaviors are things that can be adopted immediately, but many are not. And working researchers may not have protected time for study to learn new skills the way they did in graduate school. So we designed an open online educational program for biomedical researchers, the Data and Analytics for Research Training Program, or DART, that Elizabeth was just describing. And the goal is to provide training in reproducible data science methods using open source software and tools. As Elizabeth mentioned, DART provides short modular tutorials so that learners can use their time efficiently and work on just the skills they need. In addition to building the program and the materials that Elizabeth was just walking you through, we did also run a study measuring DART's effectiveness. We wanted to know more about this population of learners, and we also wanted to test whether this kind of educational approach could meet their needs. So participants first filled out a needs assessment survey for us, asking about their current expertise and interest in learning a range of data science skills, as well as the relevance of each to their work. From those responses, we used hierarchical clustering to group together learners with similar profiles and created tailored pathways of learning modules for each. We then asked participants to rate their current level of agreement with a number of important tenets of open science and also their current level of ability on a range of reproducible data science skills. That was our pre-test measure. Participants then had 16 weeks to work on their learning pathways, all on their own schedule. And Elizabeth did a great job of describing the materials and the design, so I won't belabor the details of those things. But at the end of the program, we asked the participants again to rate themselves on those same items from the pretest, measuring their attitudes towards open science and their ability to actually engage in rigorous, transparent research. Our main hypotheses were that learners would improve from pretest to post-test in both their level of agreement with open science values and their ability. All of the Dart materials are free and publicly available under a Creative Commons license. So our audience is a global one. And indeed, for our research participants, we recruited biomedical researchers from all over the world. About a third of our participants were from the Children's Hospital of Philadelphia, our institution. And a quick aside here, currently we only publish in English, but we're very interested in translating our materials. So if that's something you might be able to help with, please reach out. And we do try to practice what we preach. So the hypothesis tests that I'm presenting today are all pre-registered. We worked hard on our pre-registration and we're very proud of it. So definitely go and check it out if you want to verify. All of the analyses were conducted in R, the open source statistical programming language, and our code, documentation, and de-identified data are all publicly available on GitHub, as well as through our OSF project page. This is a lightning talk, so I'm going to skim over a lot of the details and only present a subset of the findings. But if you're curious to learn more, please do reach out. So first, let's examine the ability scores. We asked participants to rate their own ability on a range of different data science tasks on a scale from 1, I wouldn't know where to start, up to 4, I'm confident in my ability to do it. The tasks were things like build a data processing pipeline that can be used in multiple programs, or use open source tools for data visualization. For each participant, we took their average across all of the skills as a rough overall measure of their ability. And that's what you see plotted on the histogram here. You can see there's a lot of variability, of course, but most of our participants were somewhere around an average of 2. I could struggle through, but I'm not confident I could do it at pre-test. And then at post-test, we see significant improvement in ability. And this is a large effect size here, the Cohen's d of 1.1. As an educator, I particularly like this plot because you can see the bulk of our learners move up on the scale so that at post-test, they're mostly around 3. I could probably do it with some trial and error. So basically they're moving from, I don't know if I can do this, to this is hard, but I think I can, which I love to see as an educator. Also of note here is the fact that while all participants are assessed on the same set of data science skills and open science values, the actual content of individual learners' pathways differed. And for any given participant, many of the measured skills would not have been explicitly covered in their modules. Although more targeted measurement, so just assessing the skills that we've explicitly taught, may have resulted in us measuring more dramatic gains, a big part of our pedagogical design for DART was around building metacognitive and psychosocial skills, such as resilience to failure and reduced imposter syndrome. It's our hope that DART participants come away with an improved ability to learn new data science skills, including on topics that we don't currently cover, an ability that should serve them well throughout their career in a rapidly evolving field. Seeing our participants report dramatic gains in self-reported data science skills across such a wide range of topics suggests that DART might be working. Our second main hypothesis was that we would see an increase in the endorsement of open science values from pre-test to post-test as well. But as you can see from the histograms here, we had the excellent problem that our learners already strongly agreed with open science values at pre-test. So for most, there was no room for improvement. Because we did have a decent sample size, there is still a statistically significant improvement from pre to post in the open science values, but it's a much more modest effect size than we see for ability. I want to draw your attention here to just the pre-test scores in particular for a moment, because I find the juxtaposition of the open science values and the data science abilities at pre-test particularly compelling. Our learners are falling mostly between agree and strongly agree, averaged across a range of open science values at pre-test. So we're seeing really strong endorsement of statements like, open and efficient data sharing is vital to the advancement of the field. But then, when we ask them to rate their ability to actually do things, like make my data reusable by other researchers and use standardized data formats and vocabularies for my field, they're telling us they don't know how to do that. As an educator, this underscores for me the importance of providing practical, efficient training in open science techniques and tools. And it tells me that I can get off my soapbox a little bit. We have a body of learners here who are motivated to engage in best practices for open science. They just need some instruction to help apply those values in their own research. We did also ask participants directly about their experience in an exit survey to help us improve the program. And they indicated that they found it useful, with 74% saying that they learned things they can apply directly in their own research, and 87% saying they intended to continue studying with the DART materials, even after the end of the program. We're now very busy transitioning DART from a research program to a standing resource, as Elizabeth described. And we're also writing up our results for publication, as well as, of course, continuing to create and publish new learning modules. So if you want to stay in touch, please sign up for our newsletter. I want to end by acknowledging the many people that have contributed to DART. This has definitely been a team effort, and also to thank the NIH for funding it. And last but not least, to the many developers and volunteers who create and share the open source tools that have made this work possible. Thank you.
Fantastic. Thank you, Rose. I learned a ton, and I'll probably be in contact with you as well. Before we move on to our next speaker, I'm going to ask super nicely to the audience, make sure that you're on mute, just as a respect to the speakers. Next, we are going to have Elizabeth Holmes and her team talk a little bit about open science for marine scientists. I'm interested in this. Go ahead. You might be on mute, Elizabeth, but I think we do see your slides if you want to share them. I think if you top right-hand corner, there's a share button, orange. There you go. Oh, maybe not. How about view? Is there a presentation view? Yeah, presenter view. Perfect.
Okay, I figured I couldn't get it to get the dashboard so I could unmute. All right. Hi, everyone. Really happy to be here, and I'm going to be taking you to the other side of the world, to India, to talk about some another sort of a data science learning program. And this is a program with the Ministry of Earth Sciences in India. I've been involved with doing training there for about 7 years. And these are my collaborators here who were very involved in this effort. So a little background. This is focused on ocean scientists. And the background here is, ocean climate change is happening. It has happened already, and it's going to continue to happen. This is an image from a paper in 2021 showing the increase in the ocean heat content relative to 1981 to 2010. You could go online, Google, find hundreds of papers showing effects of ocean climate change. And these changes have many impacts on global fisheries, all kinds of impacts. And for countries like India that have coastal artisanal fisheries, artisanal means that they're small boats. It's not large mechanized boats. These are smaller ones like you see in these pictures. These types of fisheries are much more heavily impacted. So this picture up here is a picture I took when I was in the southeast coast of India last summer. And those are boats that fishermen go out in. That boat is a little taller than a bit taller than I am. It's probably 7 feet high, very small. And they're going out that with nets. So you can imagine for a fisherman like that, going and like chasing the fish as the fish move in response to ocean climate change. That's not an option for them. And also in many of these countries like India, there is a much higher dependence on fisheries for food security than we see in other countries like the US. So we know that climate change impacts are exacerbated by a disparity in resources. So, if we compare the global south to the global north. And that disparity also extends to the scientists in these countries, those people who need to lead the science and the innovation. And I work in the area of geospatial computing using large climate data, earth data in our applications for fisheries. That's my research area. And there's been a lot of innovation in this area. But young scientists in the global south are missing out on this because of not having access to the training, and also kind of differences in the types of training that someone in marine biology would receive relative to the same graduate student, say, in the United States. So they're not getting the same training in computer science that would be part of like a graduate program or a master's program in marine science or fisheries. And that has real implications because we have a lot of like hack weeks and training things in this large, open, collaborative communities, but there is a barrier to get in. They will ask, you have some experience with Python, you have some experience with these tools. And if these young scientists don't have experience, they just can't enter and enter those communities. So this is a project to bring these tech trainings to ocean scientists, young ocean scientists, particularly early career, but not only early career. In India, I've been involved in India for 5 years doing this kind of training. And so I put up the top there, tech bridges start with people bridges. It's having those connections. These are all people in this picture are very committed to the ideal of sharing knowledge, open infrastructure, open source. And the people in this picture, the ones with the arrows here, were then involved in this bigger 2-week hack week that I'm going to describe in September 2023. So we brought about 60 participants. We had 170 applicants. We were going to take 70, but unfortunately, all the people we invited from East Africa could not get visas. So we had participants from all across India and Bangladesh participating. And they spent 2 weeks together doing this hack week and learning these skills together in a very psychologically safe, warm, welcoming environment. What does a hack week look like? So it's a very immersive way of learning and where the participants are driving the projects and driving what they learn. So we started off with a lot of ideation activities. These are marine scientists. They know what impacts are affecting the Indian Ocean and Bay of Bengal. And then they pitch a project, their own project. Then they spend time working. I have to always tell people this image is not staged. This is me right here. We had no idea. It just was perfectly set up there. And then at the end, they present what they worked on. And this is very collaborative. Even though they have teams, they're getting help from everybody within the group. And also we had international helpers who signed on every night from previous hack weeks that I've been involved with in the United States, and they just jumped in and worked on problems with the participants. So one of the big things that we wanted to train people on was Jupyter hubs. These are very important within the big data geospatial community. There's a lot of tools that you can have set up in a Jupyter hub. It can take a really complex environment. Nobody has to install anything. This is really important. Our participants are coming with all kinds of different computers. You can jump into the Jupyter Hub and start working in a complex geospatial environment on a tablet, right? You're just interacting through a browser. These are very widely used, and often when people want to apply to these other hack weeks that are in the geospatial community, one of the prerequisites is that they have some experience with Jupyter notebooks. So that was part of, like, we needed people to start getting more experience using this platform. Nobody in the hack week had ever used a Jupyter Hub. Some of them had used Jupyter notebooks. I also added this little bit here. So the Project Jupyter, which is behind Jupyter Hubs, also got the award for Champions of Open Science on yesterday. And by help from 2I2C, and yep, I'm just about done, and ESEP, they funded our own Jupyter Hub. That's what we used. And so in the orange here, this is what we achieved during this hack week. It's building the skills. This is a 5-year project. And so we're building the base skills, getting the people network who want to work together. And then this coming year, we'll be building on that to do some more advanced projects. Thanks very much. And it was really great to talk with you.
That was fantastic, Elizabeth. Thank you so much. So now I'm going to pass it off to a friend of mine, Gizem Solmal-Raslav. I don't even know if I pronounced that right. I apologize, Gizem.
No, you did an amazing job.
I tried. I don't know. I was practicing. She's going to tell us a little about a framework for sharing educational data.
Thank you, Daniel. Hi, everyone. I'm Gizem. I'm a doctoral candidate at Florida State University in School of Teacher Education and also COS ambassador. I'm here today with my academic advisor, Dr. Robert Sean. And Dr. Sean, if you would like to say hi really quick.
Hi, really quick.
Sorry. And today we actually wanted to share our journey of data sharing in our lab. First, I will put a link to a blog post that we wrote for Center for Open Science, and I will actually move forward with using the blog throughout this presentation. Oops, sorry. Okay. I've been working in Dr. Sean's lab like almost 4.5 years now, and a couple of years ago in one of our big lab meetings, he told us that he would like to apply open science practices in our lab. And back then we were working on a research project called Foundation for Success, Developing Effective Mathematics Educators Through Cognitively Guided Instruction. And I was at the time I was part of the data psychometric team where we were doing the analysis, and he told us in that meeting we should look for some examples, some concrete examples to start, think about how we can share our data. And after doing a quick research on it, we realized that there were not many great guidelines when it comes to sharing educational data. Especially, I remember I was heavily looking at open science framework, and some examples that I found, some projects that they were sharing data or their replication codes, it was very hard to make sense what they represent, because either they didn't include data dictionaries or there was no explanation about their codes or the data itself. So that was the first time we immediately recognized the importance of yes, we are going to share data, but we have to do this so that others can make sense what we are including. And as you can see in this photo, our project was very complicated and big randomized control trial with 6 constructs in it, which had we were measuring teacher knowledge, teacher beliefs, teachers' instructional practices, student knowledge, student anxiety, and student attitude. And we used many instruments with many different data collection time points. So today I would like to talk about K-Team because I have very limited time. So K-Team is where we measure teachers' mathematical knowledge. And as you can see here, we had 5 different data collection points for K-Team. So creating this graphic gave us a big picture of the project, but to translate this picture to OSF, we realize it's a totally different experience. So this is in one shot how our project looks like, and this is how our project looks in open science framework. So under the foundation for success project, we have, like I showed you, like these are all the different instruments that we used for data collection. So when we go to K-team, when we click the K-team, under the components, you are seeing different times of data collections where we share, like for each and every other wave, we have table of contents, executive summary, data, psychometric analysis and results, and test blueprints. So I would like to show you today is K-team 2021. In this year, so when we first start sharing this data, our aim was to show like what journey we have when we are writing our psychometric reports or when we are completing our analysis, so that other researchers can verify our findings, or the scary thing about this, or find our mistakes if we made any on the way. So like to be able to fulfill, like to be able to tell them every other story we have, like when we are sharing data, we just didn't share, oh, here is our clean data, just download it and use it. So we wanted to share with them like our original data, which is what we export from Qualtrics in like different formats, because we acknowledge, some users has access for some of the softwares where some other researchers doesn't. So we decided to provide as much as different file formats we can. And after we do we go over cleaning, we also shared like these different steps. For example, like under the clean data, you are seeing actually the data generated when we did the missing data analysis. I will try to be not so technical about this, but so most of the research papers I read like says, 40 cases removed because of the missingness, like because they didn't answer 50% of the questions, but we never really see like what other rules are happening or like what codes they are using in the beginning. So that was another component that we wanted to include. So when we were sharing our codes for any of the analysis we done, for example, you are seeing one of our CTT analysis syntax here, we start writing some explanations. Before we start using open science framework, what we were doing is like in our psychometric team, we were just writing these syntaxes, because if I'm understanding what I'm doing, like when I don't need to explain to any other person, I didn't need to write those. And the examples we were able to find didn't include those explanations. It was making it hard for us to make sense, like, where they used what variable or why they selected some of the thresholds in their syntaxes. So we decided that it's not going to work if we just dump here like what we are using in our original syntaxes. So we started to write some explanations, like as you read, like we are saying that, oh, like through this code, we are like calculating corrected item total correlations, and looks like we removed like one of our variables, where we explain in every other section here, like we have this executive summaries, we write that detailed like why we gave those decisions while we were like writing those codes. And we also started like including some data dictionaries where we include like very detailed information related to our data. So throughout this journey, it was very scary because we were so scared that we would share, some identifiable information about our participants. This project included around like more than 30,000 students and 10,000 teachers. So it was very scary. And as an early career researcher, it was very scary to me that, because I was thinking like we can share my codes, but then what if other researchers find mistakes on them? And but however, we learned that this anxiety actually Oh, I'm so sorry. So this caused some anxiety, but we, I guess, learned to use it to become more creative on the way. So one concrete example I can give is when we first started like creating those templates, we realized that like in our, in our team, everybody had their own understanding of like naming the files. For example, psychometric team had their understanding, data entry team had their understanding, which was causing us a lot of issues. But first thing we realized, if we are going to share our data in OSF, we all have to have the same convention when it comes to like, naming the variables and all their stuff. And when we first start sharing, like we are using M+ for some of the analysis that we are doing, and we realized that we cannot put more than like 7, yes, Daniel, I got it, like 7 characters for the codes that we are using, because it always made sense to me because I know what I was working, but when we exported our data, other users weren't going to make sense. So, and other thing that we realized on the way, I think it definitely improved like our data management and like, data analysis practices, since we were sharing everything openly with the world. And last thing I would like to acknowledge is that, we are realizing this is still work in progress. We still have a lot way to go. And every time we share data, we realize that next time we should do this differently, or like next time we should improve this, like create this more more meaningful way. So we originally designed this talk like where we can interact with you all, but if you would like to reach out to us and extend this talk, we are happy to do that.
Wonderful. Thank you, Gizem. Our final presentation is from Sam Tilipsky. I keep tripping up on that one. I apologize. I was practicing, I swear. From UC Berkeley and the Bay Area Open Science Groups. I'll let you introduce your team and what you guys are doing.
Sounds good. All right. Thanks, everyone. And thanks for sticking through to the end. I know it's been a long few days for all of us. I feel very at home in this session, so I'm happy to be able to close it out. We've had a lot of really interesting talks so far. So my name is Sam Teplitsky. I'm the Open Science Librarian at UC Berkeley and the co-convener of the Bay Area Open Science Group. Today, I will switch over. I'll tell you a bit about the Bay Area Open Science Group, then about the Open Science Team Agreements template that we've created, and finish up with the carpentries lesson that we have based on the team agreement. So for a bit of context, the Bay Area Open Science Group draws from 3 different institutions in the San Francisco Bay Area. I mentioned that I work at UC Berkeley, and my co-conveners Ariel Deerdorf is at UCSF, and Sam Willaret is at the Stanford Medical School Library. We have pretty different settings, but we all share this commonality of introducing open science at the local level to our constituents. We are a virtual community for students, staff, and faculty on our different campuses. And then increasingly, we have various friends and colleagues who join from outside of these institutions. Our goal is to increase awareness of and engagement with all things open science. And we define that very broadly, including articles, software, open educational resources, everything kind of under the open umbrella. We host monthly virtual meetings with a featured speaker, generally someone from one of our 3 campuses who shares a project related to open science. And this is just a sample of recent speakers from the past year. So you can see we've got a variety of different topics at different levels with speakers from, as I mentioned, our campuses and kind of elsewhere as we encounter people in meetings like this. So apart from the informational aspect of sharing knowledge about open science, we spend a lot of time thinking about how to make our sessions a collaborative experience. We maintain an open notes doc, screenshotted here, to track participation and questions, and then we generate a reflection document each year to think back on themes that have emerged and reflect on what we can do better. Our audience varies a lot from topic to topic, and people kind of often dip in. We have some regulars, but we have people who dip in based on affiliations of speakers and the topics themselves. And this includes anyone from our campus's students, faculty, administrators, staff, from kind of people more on the early career side to more established participants. And similarly, their familiarity with open science varies. So we try to offer sessions that are pitched at all different levels, from things like work in progress, so people can really see the back end and how things come to be, to tutorials, policy updates, and new and emerging topics. And often we find that speakers we invite and speakers who join us don't necessarily identify as open science people. So it's really interesting to hear us give them that moniker and see how they sort of react to that in a moment. So after many of these sessions, we felt like we were encountering a lot of open science practitioners that could use some guidance on how to help them organize their workflows to incorporate open science. And I was really kind of nodding along with some of the earlier speakers who seem to be in similar spaces. So our challenge was to create a document or a tool that addresses this buffet of practices that can be open science. We started working on the agreement among the co-conveners of the Bay Area Open Science Group, and then we've sought feedback from our community participants to strengthen our first go. So with this in mind, we created a modifiable team template inspired by lab group manuals. And the template describes several open science practices with a short blurb and then a link to learn more. And the idea is that labs or teams can use this template to start conversations, to learn about open science, and to commit or recommit to practices. It can be edited and revised as these practices change. So the template covers both the products and the process of science, starting with authorship and collaboration, articles and research materials, data and code, and then communication and impact. And we've tried to make this something that's both general and adaptable to people's specific needs. Here is a screenshot to show you what it looks like. The areas highlighted in yellow indicate areas where users can edit and customize. We've shared the template on Zenodo. It's also offered as a Google Doc and an overleaf version for LaTeX users. It's been shared a bit in the past year or so and downloaded, but we're still kind of working on adoption. So it's been out in the world, and what we've been doing for the last maybe 6 months or so is taking steps to promote it. This past summer, 23, we received a subgrant from the UCLA IMLS funded project Lessons for Librarians in Open Science. And we worked with a cohort of grantees to build open lessons based on the open science team agreements. And this is really to guide people like librarians and others who have kind of an administrative role in open science related outreach. In the winter and fall of 23 and into the past few months, we've been using this as an opportunity to pilot and promote the agreement and continuing to seek feedback from a broader audience. So to dig into the lesson a bit, the lesson was created with the Carpentries Workbench. If you're familiar with Carpentries, software Carpentries, data Carpentries, there are a series of lessons that people can use and adopt based on kind of similar to the modules that were mentioned earlier, to skill building on different kind of technical topics. So we use the same platform. And here is a snapshot of the main page of our lesson. And you can see the 3 episodes on the side. The first one introduces people to the Open Science Team Agreement and a bit about open science in general. Then we demonstrate how to work with it. And lastly, we have a big focus on outreach. We then kind of segue into some interactive case studies. And we want to model to people what it looks like to really customize this team agreement for a particular group. And we have an example researcher, people can read that scenario and then have these learners can then suggest further edits and sort of think about how they might apply that with real cases. Then, as I mentioned, we spent a bit of time on outreach because outreach is challenging, and we offer different approaches to get people over that hump, with some tips to how to find champions who might want to use the template, language for outreach, emails, and a customizable slide deck and handout that they can adapt locally to kind of meet their individual audiences where they are. So with that, we're happy to have people spread the word and use and share the team agreements with your own communities. Let us know what works and what doesn't. Check out the lesson, which is still, I believe, not even in beta, but in alpha mode on carpentries. And you're also welcome to join us at any of our future open science community events. We meet the third Thursday of the month at 2 p.m. Pacific, and you can find kind of details about the Bay Area Open Science Group, links to the template all here. And I haven't posted the slides, but I will when we finish up. So thank you.
Thank you, Sam. That was really fantastic. I'll probably be in contact a little bit about all of your amazing work as well. And thank you to all our speakers. You guys did a really fantastic job, and I learned a ton just about all the amazing work that you guys are doing with your communities. With that, I'd also like to thank the audience for attending, this year of Open Science Conference. I'd like to end this in true open science fashion. If you found someone that is speaking about something that you are interested in or an initiative they're putting on and you'd like to help out, don't be a stranger. Reach out. I'm sure they would love to hear from you. With that, I thank you guys, and I'm going to end this lightning talk and have a great rest of your day.